Alright, let's look at a few more property logarithms, and we're going to go with product property, quotient property, and power property. Now, each of these I wrote as a base A, but they work for any base that you want to use, including natural logs or base E. So first one says, for product property, if we have log base A of some multiplication here, I can actually split this into two separate parts. So one thing I could do with that, I could have something that looks like this and say, alright, find, and let's go with base 10, so log of 6, and say I want to find some solution for that. Well, 6 is 2 times 3, so there's my multiplication, and then that tells me that I can find log of 2 plus log of 3. So again, it's just another form. And would it be just as easy on this one, being a base 10, to say log of 6 equals and find out what it is? Yep, but eventually we're going to have to do some proofs, and we're going to have to solve some equations where we're going to have to do some adjustments like this. So that's how that one works out. It works both ways. We could start with the split log here and be asked to put it back together into a single logarithm. So it goes both directions. All right, what about our division here? Let's do this next one as a base E. So let's do a natural log. And on this one it's saying division goes with subtraction. So let's say we've got 2 over 27. But remember, this is log base E of 2 27ths. And I'm just going to put it in parentheses. You don't have to. If you put it in the calculator, you should. So this one just says take the top and subtract the natural log of the bottom. So just remember, multiplication goes with addition and vice versa, and here division goes with subtraction and vice versa. Now, one of these other properties here, our power property, is actually one that would have helped us out with some of our earlier properties if some of the numbers turned out to work out in the way we needed them to. So one thing we could do with these is, let's take a look at one that looks like this. We're going to do log, and this time we're going to do a base 5, and we're going to do the third root of 5 as our value. Alright, now I can rewrite third root of 5 as 5 raised to the 1/3 power. And if you look at what the formula says here, it says whatever my exponent is, I can throw out in front of my logarithm. So here I'm going to take my 1/3, throw it out in front of the logarithm. Now, using one of our earlier properties, we know base 5 of 5 in terms of logarithms, this is going to equal 1. So I'm just going to get 1/3 times 1, which equals 1/3. So I found an exact solution to something that started out fairly ugly, but because of using a property where I can take my exponent and put it out front, and then using another property that we learned earlier, I can actually simplify and get an exact solution. So that's one way that we can use properties of logarithms. But let's look at another couple situations where we can run into this. Alright, let's look at a problem like this. We're going to do log base 4 of 5x to the third y. And what they're going to ask us to do is expand this. In other words, take it from multiplications and exponents and expand it so we only have one letter or one term per part. So this one, since I've got the multiplication here, let me rewrite this in a form that looks like our property. Oops, base 4. This would be the same as saying 5 times x squared, or what do I have there? X to the third times y. And remember, multiplication goes with addition. So I can write this as 3 different terms split with addition. So log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. Now we really don't want to leave that exponent there since we have a property to take care of it, so let's do one more step here. So we'll say log base 4 of 5 plus, and we're going to swing this exponent out front, 3 times logarithm base 4 of x plus log base 4 of y. So that would be the expanded using product and power properties. So this line would give us our solution. So each one of these has one base, one value, one base, one value, one base, one value. We've expanded it. So let's take a look at another one. Same idea, same kind of problem. This time let's start with a natural log. And this time we're also going to do a fraction. 3x minus 5. We're going to put that under a square root and see how ugly we can make this thing. Alright, so we've got that. So let's make one little change here. We'll keep it a natural log. On top, this is a square root, which is the same as saying that whole thing raised to the 1/2 power, all over 7. Now if you remember by our quotient property, it says division goes with subtraction. So we can have our natural log of that value on top, 3x minus 5 raised to the 1/2 power, subtract natural log of 7. And we can take this one more step, again by swinging my exponent out front, and I can get 1/2 times natural log 3x minus 5 minus natural log of 7. Now one thing to notice on this one, it looks like I should be able to do a distributive property here, but remember 3x minus 5 is one value that I'm finding a logarithm for. So don't try to distribute a natural log or a log over a quantity that we have to simplify there. So that would be my solution for my second problem. So if they're asking you to expand, that's all they're looking for is a problem like that. Alright, now, could we go the other way? Sure we can. And what do I mean by the other way? Other way might be they already have something expanded. They want you to condense it back into a single term. So let's start with one like this. 1/2 log of x plus 3 times log of x plus 1. And that just got really sloppy. So 3 times log x plus 1. Alright, so think in terms of what we've already talked about on these. Since this is a plus, it basically means I'm going to take and put some of these things back together. Now, a few other things to look at here. Remember, if we have a coefficient out front, that coefficient came as an exponent. So let's take a look at that first. So I'm going to get log of x raised to the 1/2 power plus log of x plus 1 all raised to the 3rd power. Now if we look at our product property, goes with addition, means we can take the two parts that we've got individual logs for, this part and this part, they can go back together as a multiplication. So this simplifies into log of x to the 1/2 times x plus 1 all to the 3rd power. Now, but the only other simplification I can do here is x to the 1/2 is the same as square root of x. So I can write this as log of square root of x times x plus 1 to the 3rd power. And for the time being, we didn't really accomplish much more other than follow the directions and condense into a single solution, or one single logarithm instead of separate logarithms. So let's take a look at another one here. Let's look at one like this. we'll go natural log this time, and we'll say 2 times the natural log x plus 2 minus natural log of x. So let's go back to a couple things we just talked about. Any coefficient can go back up and become an exponent, so let's take a look at that first. So we're going to get natural log of x plus 2 all to the second power. Still haven't done anything with this subtraction, but now these two parts, subtraction goes with division, there's our numerator, there's our denominator. So this is going to equal natural log x plus 2 all squared all over x. So again, not a lot to this, it's just changing from one form to another form. So not a whole lot to go with that. Now let's look at one last problem here that's maybe going to look a little uglier, and just because of the way it's set up, it maybe will turn out that way. Let's see if it does or not. 1/3 times this entire quantity, log base 2 of x plus log base 2 of x plus 1. Okay, it looks a little nastier than what we had before, but just like anything, we're going to work inside out. So on this one, I've got log base 2 of both of these, and there's an addition, which tells me product property says I can put those back together. So let's do that. We'll put those back together. So we're still going to keep our 1/3 out here. We're going to turn the 2 inside into a single logarithm of x times x plus 1. And then this half power, remember, or this exponent out front as a coefficient, can actually, in 1/2 magically turn, or 1/3 magically turn to 1/2, that should be 1/3, that can actually become my power of what I'm trying to find the log of. So we're going to take this and swing it out back. So we're going to get log base 2 of this all raised to the 1/3 power. Now if you want to make this, you know, we can put this together. I don't know if it's really going to simplify a whole lot and distribute the x. So we get x squared plus x all raised to the 1/3 power, and we don't like to leave fractional exponents, so we could say log base 2 of the 3rd root x squared plus x. And this would be our condensed version of what we started with. So again, a couple forms we can look at. We try to get rid of the fractional exponents. Could I have left this x times x plus 1 under the radical here and then did 3rd root? Yeah, you sure can. It's just another option to deal with. So that's section 3.3.